All right, good morning, Miss Nick students, and welcome to Neuroscience. We're going to be learning about brain plasticity today and a very cool way that you can actually change the way that your brain looks. If you are ready, please put a thumb up in the air if you're ready to learn about brain plasticity. If you are ready, please put your hands back down in the ready position. Okay. To start off, I'm going to need you to take your right arm and move it up like you're sitting in an armchair, nice and comfortable. Well done. Now put your armchair arm back down. Now use your left arm and put it up like you are sitting in an armchair. Now put it down. Take your right leg and stretch it out in front of you. Good. Put your right leg back down. Did you know that when you're moving the right side of your body, move the right side of your body up, it is actually the left side of your brain that is telling you to do so. So if the left side of your brain is telling the right side of your body to move, what do you think tells your left side to move? What do you think? Please lean forward and tell your shoulder partner.
The right side of our brain.
Okay. Students are back in the ready position. Who thinks they know which side of your brain controls the left side of your body? Naomi?
If the left side of your brain controls the right side, like the right side of your body, then the right side of your brain controls the left side.
Well said. Her logic was, if the right side of your brain controls the left side of your body, then the left side of your brain should control the right side of your body. Absolutely. Moving on, so we created a cause and effect here. And these are the 3 questions that you should be able to answer today after today's lesson. The first one is, what are the ways we label the cerebral cortex? And if you look down, you already have your piece of paper there. Do you see that illustration? That is of a cerebral cortex. So you can go ahead and label the top of that with our new vocabulary word, which is cerebral cortex. Cerebral cortex.
The top one?
Yep, you can label the top of your brain, cerebral cortex. Well done. Question number 2 that you are supposed to answer, what are the different functions controlled by the cerebral cortex? And the last question is, what is brain plasticity? And this will, I guarantee it, this is going to be the item that you're most excited about at the end of today's lesson. Okay, so what are the ways that we label the cerebral cortex? This is the first question that you are expected to answer. 85% of your brain is the cerebral cortex. Is that the majority or the minority of your brain mass? Majority. How did you know that that was the majority of your brain mass?
Because if you would round that up to the nearest 100, it wouldn't be 100. It would be 100 because if it were 50, then it would be in the middle, but it already has 50, so it has to so it's like closer to 100.
Well said. 85 rounds to 100, so the majority of brain mass is going to be your cerebral cortex. Now, the cerebral cortex is broken into different parts. The cerebral cortex is broken into different parts. You have the left hemisphere and the right hemisphere. This word hemisphere, you know that it means something in Greek. Who can break this word down, hemisphere, into the Greek roots? Yes.
I remember from social studies from the world.
Hemi means what?
Round.
Sphere means round, and hemi means, how many parts is it broken into if it's hemi? Half. So half of your sphere. Half of your sphere is left, half of your sphere is right. So we've got the left and the right hemisphere. Your illustration has the 5 lobes: parietal lobe, frontal lobe, temporal lobe, cerebellum, and occipital lobe. I say parietal lobe. You say
Parietal lobe.
I say frontal lobe. You say
Frontal lobe.
I say temporal lobe. You say
Temporal lobe.
I say cerebellum. You say
Cerebellum.
I say occipital lobe. You say
Occipital lobe.
well done. Okay, and now here is an illustration. Do you think your brains are really this color? No. What was the author's purpose here? Why would the author color the different lobes of the brain? Please quietly turn and explain why to a face partner in 3, 2, 1. Excellent. Great strategy. Students are back in the ready position. What do you think the author's purpose was for coloring the different sections of this brain? Yes.
It's like how a map does it, so it can tell different parts away from the other.
That is a great connection. This is a lot like when we're looking at maps and how we know that on a political map, China is not really the color purple. But it's easier to see where China is if it's a different color than Europe, if it's a different color than South America. The same practice is going on here. We have our frontal lobe, and where is that located in your brain? In the front. Excellent. Your temporal lobe. Has anyone ever rubbed your temples when you were stressed?
Yeah.
Absolutely. Okay, so where do you think your temporal lobe is located? It's behind your, what are these called? You have your frontal lobe here, that's right. And this is your temporal lobe because it's at your temples. It's at your temples, your temporal lobe. You may make these two labels at this time. Now you have the cerebellum, which even though this mass is a lot smaller, this controls a lot of the functioning of your body, and that's close to the brain stem, the cerebellum. Your occipital lobe is right here, and I know that your occipital lobe has a lot of connection with your vision. And now you have your parietal lobe, which is also towards the back of your head. I will give you 20 seconds to add these labels to your study sheet, which you will need for your exit card. Frontal lobe, I say frontal lobe, you say
Frontal lobe.
I say temporal lobe, you say
Temporal lobe.
I say cerebellum, you say
Cerebellum.
I say occipital lobe, you say
Occipital lobe.
I say parietal lobe, you say
Parietal lobe.
That's right. I'm going to point to a section of my skull, and I would like you to make an estimation of which lobe I'm pointing towards.
Frontal lobe.
Whisper it to me in 3, 2, 1.
Frontal lobe.
Cerebellum, well done. Right here. Occipital lobe. The occipital lobe is here.
Temporal lobe.
Temporal lobe, well done. One more time right here.
Frontal lobe.
Frontal lobe, by your brainstem, that is a cerebellum. Okay, so how would you label this brain? Who can remember what was this chunk of the brain called for review? Yes. You can look down at frontal lobe, well done. And close to the, so we have right here by the brainstem, it controls a lot of your functioning. What was that called? Yes.
Occipital.
Close. This is the occipital. This is the
Cerebellum.
cerebellum. And here is the occipital, well done. And parietal lobe. Parietal lobe. And by your temples, this is the temporal lobe. Well done. What about this brain? How are we looking at the division of this brain? How is this brain divided? Please lean forward and tell a shoulder partner at this time.
They're divided by half.
What are the two names of these sections? What are the names of these sections? Yes. That's right. Right hemisphere and left hemisphere. Well done. Okay, our second essential question. What are the different functions controlled by the cerebral cortex? So looking at the frontal lobe, I say frontal lobe, you say?
Frontal lobe.
I say temporal lobe, you say?
Temporal lobe.
I say cerebellum, you say?
Cerebellum.
I say occipital lobe, you say?
Occipital lobe.
I say parietal lobe, you say?
Parietal lobe.
Good. This is temporal lobe. And by your brainstem,
Cerebellum.
cerebellum, well done. That's 85% of your brain. Here are some of the things that it controls. Higher order thinking. Sensation, which would be your 5 senses, that's right. And your Movement. And remember, when I'm moving the right side of my body, which hemisphere is thinking about that? Yes.
The left.
The left. If I move the right side of my body, whisper it to me. Which half of my brain is working? Which hemisphere? The left hemisphere. That's right. Okay, now thinking back to that list, can you create a list of functions your brain does? Movement, thinking, and sensation, which is your 5 senses. On the back of your card, would you please take 10 seconds, make a list of the functions that your brain controls. Remember that movement, thinking, and sensation are all part of your brain functions in your cerebral cortex. Those are the functions of the cerebral cortex. What would be examples of function, movement, and thinking and sensation? Would you write down examples? 8 seconds remaining. Let's see what you come up with. Pencils are down. I'm going to take the first 4 students with hands up. What's an example of something controlled by the cerebral cortex? Yes. Think of your 5 senses. Yes.
Color.
Oh, seeing colors. Okay, that's right. That'd be the occipital lobe. Yes.
Movement.
Movement. Absolutely. Like kicking a soccer ball. Yes.
Like thinking.
Thinking. Absolutely. Solving a math problem. Yes.
Daydreaming.
Ooh, daydreaming. Yes, that would also be part of thinking. Yes.
Imagination.
Imagination. That's all part of the cerebral cortex. Okay, now we're moving on to brain plasticity. We know the lobes of the brain. We know what the brain does. Now let's talk about training your brain to make it stronger. I say train your brain. You say?
Train your brain.
That is brain plasticity. I say brain plasticity. You say?
Brain plasticity.
I say brain plasticity. You say?
Brain plasticity.
Our brains can actually change shape and become stronger. This is how your brain does that. Your brain will make new connections through the neurons. I say new connections. You say?
New connections.
Dr. Benjamin Carson, who was a pediatric neurosurgeon, he had a patient whose right hemisphere had difficulty staying awake in the same way that our brains stay awake. And he hypothesized, if this right hemisphere is being so problematic, what if we took it out? And what if the left hemisphere became stronger so that it could fill up where the right hemisphere was? And you know what? He was right. A 6-year-old child had this surgery, and if we were taking out her right hemisphere, which side of her body had difficulty moving? Her left, that's right. But her brain had plasticity. Her left hemisphere said, you know what? I'm going to make up for where the right hemisphere was. I'm going to become stronger. And the right hemisphere of her brain retrained itself so that it could control the left side of her body. How cool is that? Now, can you summarize this information? Even though we might be sad or a little bit scared that she had a portion of her brain removed, why was it still okay? How did her brain persevere and use plasticity to control the left side of her body? Please quietly summarize for the shoulder partner at this time.
That's because we got bigger and stronger, so we can make both sides of the body work. So then the side became stronger and took over. Yeah, it took over the right side.
Students are back in the ready position. How would you describe what happened? What did her brain do to make up for the missing piece? Yes.
The left hemisphere, it made it stronger, so she didn't have to have the right hemisphere, and
Yes.
it got bigger so it could fill in the other.
And what's that process called?
Brain plasticity.
Yes, that's right. That process is brain plasticity, where the neurons will take over, they will find new connections, and they can actually change the shape of your brain. So what do you imagine, what do you visualize is happening to your brain when brain plasticity occurs? Yes.
I think one side starts taking over.
Maybe one side might start taking over, maybe it's molding, changing shape a little bit. Yes.
Maybe it might change shape, and you might have a stronger brain than you had before.
You might have a stronger brain than you had before, which brings us to our next question. can we label this brain? We're going to go back to our last question. You're actually achieving some brain plasticity right now. You are making connections in a subject that you haven't learned before, and plasticity is happening. This lobe is at the front, so it's called the
Frontal lobe.
This lobe is connected close to the brain stem, and it's called the, yes, cerebellum. That's right. This lobe is right behind your temples. It's called the
Temporal.
This lobe is at the top. It's called the parietal lobe, and this is the occipital. Well done. Now I'm going to ask you to persuade a student. Using your new knowledge of the brain, how could you convince another student it's possible they can become smart at math? Using what you know about brain plasticity, can you convince someone else it's possible to become good at math? How? Please turn and tell a face partner.
By learning new facts.
Students are back in the ready position. What will your neurons start to do if you want to become better at a subject? Yes.
I heard from Angel that he said that like you could learn new facts. And
Yes.
And then
You learn new facts, your brain changes shape, and that is called what process?
brain plasticity.
Brain plasticity. Well done. You have answered all three essential questions. And that's what we're going to do here on an exit card. So on the index card that you have, you're going to take 2 minutes. This is our last activity. Essential question number 1, you can label it 1, 2, 3. Essential question number 1, what are the ways we label the cerebral cortex? Think about the 2 hemis. Think about the different lobes that you learned. Can you list them and can you include on your illustration the names of the different lobes? Question number 2, what are the different functions controlled by the cerebral cortex? And the question number 3, what is brain plasticity? What does that mean if I say your brain has plasticity? What does that mean is actually occurring?